So let's start. So we are going to probably start transpose of a linear transformation, right? One thing I think you all should know, that is, suppose x is x1 to xn.
দাদা
দাদা
স্ক্রিন
স্ক্রিন
শেয়ার
দেখা
করছো?
যাচ্ছে না।
Screen share, sorry. One thing I think you all should know, suppose x is here and say B belongs to MNF, n cross n matrix MNF. So what is x transpose bx? So if
স্যার রেকর্ড
B
করছো
is,
তো?
yeah, if B is Bij, what is that? This is actually x is regarded as a column matrix. Okay, so we write x as like this.
You have started the recording.
Yeah. Once you compute this, you will actually get this, like summation I running from 1 to n bi1 xi, comma bi2 xi, and so on to xi. Once you compute this whole stuff, you will actually get this bij xi xj. Okay. So now there is a thing. If B is of the form A transpose A, then what do you get? If B is of the form A transpose A, then what do you get? So we write x transpose Bx is equals to x transpose A transpose Ax. That is, you get x Ax whole transpose Ax, right? For any y, y1 to yn, y transpose y is summation yi square. Okay, so it is greater than equals to 0. So put y equals to ax, it implies x transpose A transpose Ax is greater than equals to 0 for all x belongs to f to the power n. So we have a following claim like rank of A is equal to rank of A transpose A. So how do we prove it? Let x belongs to car A. That implies Ax equals to 0. That implies right? This implies kernel A is contained in kernel A transpose. Again, if X belongs to kernel A transpose A, then A transpose AX is 0. That implies by this, from this we write AX is 0. Okay, so kernel A transpose A is equal to kernel. Thus the dimensions are equal, so we get nullity of A transpose A is equal to nullity of A. So by that, by rank nullity theorem, you get rank A transpose A is rank A. So this is a very useful thing. So there is an introduction. Like suppose we have two vector spaces over the field F, B and W. The linear transformation T V into W is induced by a linear transformation W star into V star. What is that? So say V to W, there is a linear transformation T. Okay. So suppose there is a small f. So what is it? Okay. So T induces T star from W star to V star such that f goes to f is a linear functional over W, f goes to f compose T. Okay. The linear transform as follows. Suppose G is any linear function over W. So they have actually proven that T is therefore 6 tells us that f is also linear. They have proven that this T star is actually linear. W linear. Oh, so basically they have denoted this by okay. So T transpose is linear. We shall call this the transpose of T. So one thing we have actually seen, like for matrices, like if A is a matrix in M and F, say Aij, A transpose is written as Aji, right? But you should be able to understand what is the actually meaning of what is the link between T transpose and A transpose. Suppose A is an M cross N matrix. Okay. Then A transpose, an N cross M matrix. So try to figure out how A transpose and T transpose are related. We will actually see this in a moment. Okay, so let's actually read this theorem. Like, if V and W be a vector space over the field F, let T be a linear transformation from V into W, the null space of T transpose. The range of T is the Ni. Okay. So I would request you to go through this theorem. Proofs are actually pretty elementary in this chapter. So please go through the proof. You have actually 5 to 6 minutes. Hello. Hello.
Dada.
Is it clear, right? It's a massive.
Ah,
One thing you should notice that rank of T transpose is rank of T, and we also saw that dimension of V and dimension of V star, these two were same. So you will see actually analogous results all through. Okay, so read this result. Already I think you can guess it that the matrix of T transpose has to be the matrix of A transpose, right? I mean the T transpose has to be the matrix of T whole transpose. So this theorem basically states that V and W be two vector spaces over the same field, beta be an ordered basis of beta V with the dual basis V star, beta prime be an ordered basis of W with the dual basis beta prime star. If linear transformation T has the matrix B with A with respect to B and beta prime, and the matrix of T transpose is respect to beta prime and beta prime star. I mean beta star and beta prime star is B, then Bij is Aji. Okay, so basically they are saying that uh, T beta prime, this matrix, I mean transpose of this is basically T transpose beta prime star beta star. Okay. Okay. So okay. So see, there is another a good proof of this. Like if A is an n cross n matrix, then the row rank of A is equal to the column rank of A. So what they are doing, like B is the standard basis of Fn and beta prime is the standard basis of Fn. T is the linear transformation from Fn into Fn such that the matrix T is relative to B beta prime is A. Okay. So T is defined in an obvious manner. The column rank of A is the rank of the linear transformation T because the range of T consists of all m tuples, right? And see this relative to the dual basis beta prime star and beta star, the transpose mapping T star T transpose is respectively by the matrix A transpose. Okay. So the column rank of A is basically the row rank of A transpose. Okay. So this is an obvious result, huh? Because we have seen that rank of A, I mean rank of T is equal to rank of T transpose. Okay. These are I find these results. I mean these are maybe some obvious results because you can actually get them intuitively. But the proofs are elementary as well. I mean this proofs doesn't actually require any higher technique. Okay. So there is an example, right? This example will be of general nature, more discussion than example. Let's see. Okay, so this is the last example. So I think we should be able to conclude this chapter today. So let's see what they are actually saying in this example. So suppose V be an n-dimensional vector space over the field F, and let T be a linear operator on V. Suppose beta is an ordered basis of V, and the matrix of T with respect to beta is defined by this matrix A. Okay. If F1 to Fn be the dual basis of beta, this can be stated simply, right? Do you understand why this expression is here? Because if you do Fi T alpha j, that is Fi summation j running from 1 to n Fi Aij alpha j, right? So which term will actually survive under this? Only if I equal to j, so only actually this term survives. Aii alpha I. Huh? Is it correct? Hmm? Fi is the dual basis. So Fi alpha I only will survive. Wait a minute. Rahul, am I doing it correct?
আমিও তো নোটেশনে কনফিউজ হয়ে গেছি।
T alpha j is summation Aij alpha I. So when I do Fi, the only this was the sum is over I here. Wait a minute. Okay, can be actually T alpha j is summation j running from 1 to n Aij alpha I, right? So you put if there, like if I T alpha j is summation j running from 1 to n Aij Fi alpha j, sorry, Fi alpha I, right? No, actually this I and this I are different, I guess. what problem? I mean, there is this I, the sum is taken over I. So when I am doing this, so this becomes summation AI only. Huh? How is that possible?
I I think we should change the subscript of F. Something FK.
That's why I mean that's where the confusion is coming from. Yeah, yeah, yeah. Once we change the subscript of K, this is actually Ij if K alpha I, right? So which term will survive? Only when I equals to K. Only that term will survive, right? So we get
Yes.
A Ik. So it is AKJ, right? Okay. So that is if K alpha J is AKJ, right? So that's what is written here. If IT alpha J is AI. Let's see what happens if we change the basis. So they have gone to alpha I prime and the ordered basis is this. U is an invertible operator such that U alpha J is alpha J prime. That is U is the change of basis matrix. Then the transpose of U is given by, okay. So you understand what they are saying actually. That if U is the matrix that sends beta to beta prime, then U transpose actually sends beta prime star to beta star. Okay. Okay, so given by U transpose Fi prime, it is easy to verify since U is invertible, so U transpose is this, and U transpose inverse is U inverse transpose. Therefore, beta ij, I mean bij, yeah, this is actually pretty basic. Bij is this. You understand this? Remember that T transpose F was F compose T. That's what they have actually used here. That this is actually if I compose U inverse. Okay. Now what does this say? Well, if I U inverse T alpha j is the ijth entry of the matrix U inverse Tu in the ordered basis beta. Clear? So what is your beta ij? This is nothing but alpha j prime, right? What is this? U inverse Tu alpha j. This is alpha j prime because this is the change of basis matrix, na? Wait a minute. No, U alpha j is alpha prime. Am I doing it correct? U alpha j was alpha prime, right? U alpha j is alpha prime. Okay. So this is Fi U inverse T alpha j prime. Phi of U inverse T ij the entry of U inverse Tj, yeah, right, in the ordered basis beta. Yes. So this is the actually thing that this is what we actually got, that U beta to beta prime is U, hence beta prime star to beta star is U transpose. Okay. Okay, so I think, can we do 2? What about 2? Try please. How to do it? V be the vector space of all polynomial functions over the field of real numbers a to b.
by using the definition
Hmm.
of transpose.
What is so if p is this, okay. So how are we doing it?
D transpose FP equals to FDP by definition of
F
transpose.
compose d, right? So d transpose f at a polynomial p is f of dp, that is f of p prime, right? I mean the derivative of p, that is a to b p prime x dx, right? This is, you are just integrating, that is pb minus pa, right? V be the space of all n cross n matrices over the field, over a field F, and let V and let B be a fixed n cross n matrix if T is the linear operator of V such that T is basically AB minus BA. Then what is T transpose F? This is a good problem. Oof. So
It will be zero.
sorry.
It will be zero, I think.
Okay. What is T transpose F again? That is F compose T. That is F of, so T transpose F of A is F compose T of A, that is F of AB minus BA. Why do you think it should be 0? If F is a trace function, right? That is trace AB minus BA to 0. Can we conclude anything further from this?
The 3.5 একটা এক্সারসাইজ ছিল এটা সেটাকে
সুব্রিতা
পেজ
নাকি?
নাম্বার
হ্যাঁ, কোথায় রে? পেজ নাম্বার what?
107
হুম।
ওই 16 নম্বর এক্সারসাইজটা এবার সেটাই মানে একটা স্টেপ আছে এই
So that the trace function is in the is unique in the following sense that W, the space of our n cross n matrices over the field F, and if F is a linear functional on W such that f of AB equals to f of BA, for each A and B in W, then F is scalar multiple of the trace function. Yeah, Shubhrita again, what are you suggesting?
দাঁড়াও।
Mhm. It's good that actually you can connect stuffs, or at least you are trying.
মানে আমরা যদি উল্টোটা প্রুফ করতে পারি, যদি ট্রেস
মানে কি চাইছিস দেখাতে, মানে অ্যাকচুয়ালি হোয়াট আর ইউ ট্রাইং টু শো?
না না আমার ভুলিয়ে যাচ্ছে।
Okay, fine. Mane, I think, but at least these problems have something in common. So it's good that you are actually being able to connect it.
অ্যাকচুয়ালি পরের দিকেও এই এবি মাইনাস বিএ ম্যাপ নিয়ে অনেক প্রবলেম হয়।
Actually, the fact is that every trace zero matrix is of that form. That's a result. I mean, there are some tedious computations, but every trace zero matrix is of that form. AB minus BA for some A and B. V be a finite dimensional vector space over the field F, T be a linear operator on V. Okay, I think you guys can do this. This is something I think we did, right? A is wait a minute. Prove that A is 0 if and only if trace A transpose A is 0. This is doable. Okay. Just compute A transpose A. Nothing. Just take A to be AIJ and compute A transpose A. N be the positive linear positive integers. Functions over the field of real numbers which have at most degree n. How about this? Rahul, let's try to actually do 6, 7, 8 and complete this chapter, okay?
Now,
Yeah, let's try, let's complete this chapter. Okay, and okay, tell me one thing. What should we do next? should we go to chapter 6 or chapter 8? I mean, this is the uh, content. So should we go to chapter 6, like elementary canonical forms? That chapter actually contains the eigenvectors, eigenvalues and all that. But if we do chapter 6, we will have to chapter 7 next. So what should we do? After this 6 or 7, or we do inner product spaces first and then the others? Or we just should go just, 6, 7, 8, 9 and so on. What's your preference? I think we can do inner product spaces first, right? Because that is actually a sort of common in jam and every examination, right? So once we complete that, then we can go to actually. Is that okay?
কিন্তু দাদা বেশিরভাগ ম্যাট্রিক্স প্রবলেম ট্যাকেল করতে গেলে তো 6, 7, 8টা আগে লাগবে।
Huh. But what I am trying to say is that inner product space is a bit easier. First, this actually, see, I am showing you this. You know? Oh, এটা দেখাচ্ছে না। So this is actually the chapter 6. There is characteristic values 6.2, 6.3 is what is 6.3 by the way? Annihilating polynomials. Kelly Hamilton is here, and see, I think you don't need more than 6.3 for M.Math and others, right? Then we are going to actually do some, but I think he is right in a way. Simon, 6.4 should be enough. I mean, from 6.5, Simon, this is going to actually Jordan canonical form. So, what should we do? Should we do chapter 8 first or chapter 6, 7, then 8? Because chapter 6 and chapter 7 actually I will have to teach the theory. Otherwise it won't be fruitful. Like this chapter, linear transformation, inner product spaces, the theory part is pretty easy. You can do it on your own. But actually, my teacher said that two chapters in Hoffman Kunz, the whole book, those are actually a bit difficult to read by yourself. Those two chapters are 6 and 7. Okay, let's do it first, then we actually have a week to think about it. Now, next week is holiday, right? So,
সিক্স সেভেন এইটটা স্টার্ট করাই বেটার হবে বলে মনে হচ্ছে।
yeah,
বাকি
because yeah, in a way you are correct actually, because that actually will give you an
ওটা টাইম
overall
টেকিংও
idea.
আছে,
Hmm?
একটু টাইম টেকিংও হবে 6, 7, 8।
That, yeah,
ওটা
that is actually my problem, because the fact that we have 1 month less for this net actually. Okay, let's do 6, 7, 8 actually. Skipping stuffs shouldn't be, I think we shouldn't do. Let's do 6, 7, 8 in that order. Okay, what is 6? Problem number 6. N be a positive integer let V be a vector space of all polynomials. The function of the form. Okay. So what is D transpose? So D transpose of F is F compose D, right? Find the basis of the transpose of the operator D. So
null space of D transpose.
let P belongs to, yeah. You are saying something?
So can you think in this way that null space of D transpose equals to range space of D, annihilator of range space of D? I mean the identity just
Okay.
we read in this theorem.
Yeah. We just a minute. No. He is right actually. What was that? What is that theorem number?
The previous thing. 22 I think. 22.
The range of T transpose is the annihilator of the null space of T.
No, the above line. The null space of T transpose is the annihilator of the range of
Where it is? Okay. The null space of,
16 woman.
sorry,
Oh, no. No, sorry.
the null space of T transpose. No. It is a given requirement. Okay. V W and T be the linear transformation T into V. The null space of T transpose is the annihilator of the range space of T. Oh no. Sorry. I think you are right. This is a conclusion, right? Hmm. The null space
এটা
of
এত
T transpose.
কনফিউজিং ভাবে লেখা না
Yeah. No. You are right actually. They should
মানে
write a
এটা
more.
কনক্লুশনই
No. They should write a moreover here actually. V W vector space over the field F. Let T be a linear transformation from V into W. The null space of T. Then the null space of T transpose is the annihilator of the range space T. If V W are, moreover, if V W are finite dimensional, then this happens. Okay. The null space of T transpose is the annihilator of range of T. Okay. So we are gonna use this. 22, theorem 22. That is the kernel D transpose is what? Range of image of
annihilator
D
of range.
not, right?
Yeah.
So what is that? What is image of D? Image of D is all polynomials of degree less than equals to n minus 1, right? That is image of D.
Yeah.
So image of D not is set of all linear functionals from can we just call it Pn minus 1, where
Yes.
Pn is V. Okay, this is all those f from Pn minus 1 to f. No. So f is a map from. Wait a minute.
Who are?
F is a map from V to R, right?
Yeah.
V to R such that kernel AF, no, such that Pn minus 1 is card F. Is it right?
Yes.
But I think we actually know this. I think we did a result there that I think we did something similar here. I was talking about this. If and only if the null space of G contains the null space of F, right? So basically, if the kernels are same, then G is CF, right?
Yeah.
So if kernel F equals to kernel G, then F is CG. C belongs to R. So what is this? So I can say that this whole thing is generated by a single F naught, right? True, na? Because every element in F has Pn minus 1 as kernel. So all of them are basically scalar multiple of a single map functional.
দাদা
Yeah.
Yeah,
দাদা
yeah,
হ্যাঁ এখানে থিওরেম নাম্বার 16টাও তো ইউজ করা যেত মানে 1 তাহলে ডাইমেনশন হয়ে যেত
very good. Also we can do that dimension of
মানে n মাইনাস n
V
মাইনাস
naught
1
is n minus 1 is 1. Okay, right? Yeah, right. So again, so this is a scalar multiple of a single F naught. So enough to choose a non-trivial F naught. Okay, that is an F naught which is not identically 0. Tell me an F naught which is not identically 0. So we can take this, right? F from V to R, it sends P, a polynomial, to P of 0. Okay, this is not identically 0, right? F is not identically 0 because polynomials with non-zero constant terms are not killed by F. Okay, very good. Who told about who was talking about theorem 16? Shubrita or Tiyasha?
সুপ্রিতা
Good. গেল কোথায়? এই তো। Okay, let's move on to 7. let V be a finite dimensional vector space over the field F, show that T to T transpose is an isomorphism from LVV to LVV star. Is the statement clear? Orpon, is the statement clear? We have defined T transpose for T, right? And we have seen if T is a map from V to W, the T transpose is a map from W star to V star. So similarly, if T is a map from V to V, T star is a map from V star to V star. So they are saying we define phi from LV to V to LV star, comma V star. That is T T to T transpose. Okay.
Clear.
So the thing is, okay, so we can, I think, so they are saying that this is an isomorphism. But how to say that?
So this theorem says that every unique linear linear transformation has unique transpose.
Exactly, very good. So corollary of the theorem is that T transpose is unique. Okay. Now tell me, how do we prove it? So let, one thing is obvious, I think Fs plus T is T plus S whole transpose, and T plus S whole transpose is of F is if compose T plus, I mean do it lambda here, lambda, if compose T of lambda S, that is if compose T plus lambda
If the
compose,
ছোট হাতের small hand.
yeah, this is, so that is T transpose F plus lambda S transpose F, that is T plus S transpose is T transpose plus lambda S transpose. So phi is a is a linear map, right?
Yeah.
But what about the kernel and others? Is it injective? See, one thing is true, LV to V has finite dimension, right? I think we have seen it. We have proven that LV comma V has finite dimension, right?
Yeah, for being V finite.
If V is finite dimensional, then dimension, if V is of finite dimension, and for finite dimensional vector spaces, a linear map is injective if and only if it is surjective, right? So
Yeah.
proving injectivity or surjectivity, one of them is enough.
Yeah.
So I think injectivity should be enough. It should be easier. So let phi t is 0. That is T transpose is 0. It implies if compose T is 0 for all F belongs to V star. Okay. So our claim is T should be 0. So if T is not 0, is not identically 0, then what should happen?
Then we can take a non-zero element and it will be non-zero.
no, the problem is that T is a linear transformation, not a matrix. Okay, I mean T is a matrix, we know that, but we don't have the
Yeah.
matrix form of T. If we go to the matrix form of T, then we will have to consider the some basis. I can understand what you are going to do. I mean, you are writing that T is this, so there is a non-zero entry. We will define F to be that non-zero entry, right?
Yeah.
What the problem is that T doesn't have a matrix form. So should we fix a basis of B? Okay, let's do it. Then we have to define F from V to F such that if compose T is non-zero. So consider beta a basis of V. So if T is not identically 0, TB is not identically 0, right?
Yeah.
So TB has T beta has a non-zero entry. Say at k comma L place. Okay. So we are defining if V2R, no, if is on, wait a minute. If is on V star or, just a minute. If is on V star, right? If is on V to V.
V star to R.
If is from V to R or V star to R.
V star to R.
No, F is from V to R, I think, because T transpose is acting on F, right? Isn't it? I mean, you should have, it means T transpose F is 0 for all F belongs to V star, right? So if compose T is 0 for all F belongs to V star, isn't it? So F
Yeah.
is from V to R. Okay, so I think uh, we can do this. So T, so there exists V naught or maybe alpha outside of car T, because T is not identically 0, right?
Yeah.
So consider beta. Beta is a of basis of V which actually consists alpha. Okay, I mean which actually contains alpha. Because alpha is not in car T, alpha is a non-zero vector. So I think we can extend this basis. So I am trying to define, So if x is, say, c, call it alpha, sorry, so we need to just call it alpha 1, alpha 1 to alpha. So if c is I running from 1 to n, if alpha is summation ci alpha I 1 to n, define, I think this should work, from f to x summation ci alpha x will go to c1, the coefficient of alpha 1. Okay, I am sending it to there. Now what is f compose t of alpha 1? What is that? That is f of t alpha 1, right?
Yeah.
But can we say this is non-zero? T alpha 1 is non-zero, right?
Oh yes.
Hmm?
Yes. Yes.
Then what? My point is t alpha 1 is not 0, but we supposed to have t alpha 1 not equals to 0, right? Okay. Wait a minute. Look at this adjustment. This is actually beautiful. Okay. T alpha 1 is not 0, right? So you can extend this basis, right? Now consider the dual basis beta star of beta, right? Then we have fi. So if it is the dual basis, what do we get? We get if 1 of t alpha 1 not equals to 0, right? Isn't it?
Yeah.
That is f1 compose t of alpha 1 not equals to 0. That is t transpose f1 of alpha 1 not equals to 0. So t transpose f1 is not 0. This implies t transpose is not identically 0, which is a contradiction. Okay. I like this trick actually. See how we have used actually the fact that t alpha 1 is not equals to 0. Okay, now 8. Okay, so mm, if B is a fixed n cross n matrix, and if BA is B trace B transpose A, show that if B is a linear functional on V. This you can do, I think. The part A is you can do. Show that every linear functional V is of the every linear functional on V is of the above form. That's a tremendous result. So let B is, I think, extremely non-trivial, isn't it?
Yeah.
If is any linear functional, we have to write if as a trace of some matrix. Okay, well, this is just outstanding. Do you remember, I mean, the formulation of if, I mean, the dual basis, the stuffs that we did? I think linear functional, which chapter was linear functional? 3.5. Shubhita? Hey, bol na.
3.5.
So there, I think we did a result there. That is,
ওই এক্সাম্পল নাম্বার 19 কি?
কোথায় বলতো
ও
সেটা?
না, কিন্তু এই মানে
Yeah, this is it.
এই
That
জেনারেল
this general form I was looking for. That beta is a basis. You consider the dual basis, and you see that every linear function is of this form. Okay. And for each vector alpha, we have this. So any linear transformation is basically trace of V transpose A What is trace of V transpose A, by the way? First let's write down that. Suppose B is B11, B1n, Bn1, Bnn. So what is V transpose A? What is B transpose A? What is B transpose A, by the way? B So what is okay? Just tell me what should be the trace of this. I mean, just write down the diagonal of this matrix. This B transpose A, right? That is summation B1I, no, BI1 A1I, right? So the next will be summation BI2, yeah, A2I, right? Am I doing the calculation right? সুব্রিতা, চেক কর তো ঠিক করছি কিনা। হ্যাঁ, ঠিকই করছি আই গেস। হুম। So trace B transpose A will be summation I j B I j A j I, isn't it? Right. So this is the trace. Okay. That is summation A j I B I j okay, so this is what we get, and they are claiming that every linear transformation, I mean every linear function is of this form. This result is quite non-trivial, I think.
আচ্ছা, আমরা fn এর জেনারেল ফর্মটা জানি লিনিয়ার ফাংশনালি। এবারে এখানে n ক্রস n এর জেনারেল ফর্মটা তাহলে কি হবে, সেখান থেকে কি
এই সুব্রিতা তিয়াসার গলা না একই রকম হয়ে গিয়ে সমস্যা আছে তো। It's a good problem actually, very good problem indeed. Yes, I think what Subrita was saying, that any linear functional is of this form, right? I mean, if Eij is a basis of Mn cross n, right? So call it beta. What is beta star, Subrita? Eij star, I mean if ij, I should write such that if ij Eij is not 0, 0 if, sorry, I think we should write right? This is the dual basis. And what if is any linear functional from this? So what was f's form? F was of the form this, right? So f is summation ij f of eij fij, right? This was the form, right?
Yeah.
Okay. And we know that any linear functional from fn to f was of the form summation ci ai, right? Any linear functional from fn to f is of the form ci. I mean, we know that if f is a linear functional from here to here, then f of this is actually of the form summation ci ai. We have actually done that, right? So if this is nothing but f to the power n square, so for any aij, if a is of the form summation cij aij, right? Right.
Hmm.
So now you see that what did we saw? Like it was bij aji, right? That form was. So how about we do this is nothing but summation cji aji, right? Bij aji, okay, for some cij in f, right? So define c as cij, isn't it? So then we get fa is trace of c transpose a, right? For all a. Now it is done. Understood? So that's the key. We don't actually need this, isn't it? We don't actually need the dual basis and all this stuff. Only this is enough, that any map from fn to f is of this form. Okay, clear to everyone? Can you complete this? Like b to fb is an isomorphism from v to v star. See, this actually shows that the map is surjective. Okay, like v to v star, you are going from f to fb, right? B shows, if you call it theta, B shows theta is surjective, isn't it? Because every map from V star is of this form, right?
So to finite dimensional.
Yeah, very good. So theta is bijection. এটা কে বললি লাস্টেরটা? সুব্রীতা না তিয়াশা? এই তোর গলা তিয়াশার মতো হয়ে গেল কি করে? আর তিয়াশা তুমি এত চুপ কেন? Okay, so that's it for today. Next day we start chapter 6. I expect that you guys actually see there is a 1 week gap. Okay, please read the back, please complete the backlogs. Bhushan, are you there?
Yes, sir.
Okay, please read the backlogs. I mean, clear the backlogs.
Yes, sir.
Linear algebra কত বড় কথা এটা? Okay, bye.